Okay, so this is my assignment one code video. So to begin with, we have our just imported functions, then straight down here into code. So our first function is to normalize words. So we just have def normalize word, takes word variable, and it just runs this, and this is just so it processes the data and can read the actual word and not the spaces or any other special character in the file. So down here we all the files into load all the files into the coding program and use the normalized word function. So we do this with the English file, open english.txt. Um, then we use our normalized word function in order to get rid of white space and other such little special characters. Next, we do the same for German text file and the Spanish text file. Next, we have code to balance the data set to equal the number, have an equal number of words for each language. So we find the minimum length of the um, different arrays that we stored the words into, the text files, the contents of the files into the arrays. So we just take the arrays, and whichever one has the smallest length is the length we kept. As it's the length we kept. Um, next we next we basically get that many. Once we find the minimum length, we get or the minimum amount of words from the smallest file. We use that number and get that many words out of every single file. Then we combine all the words into a singular array and create labels. So as you can see, English plus lists all the list of all the words, and then we create the labels for the languages. Next, we convert the words into TF-IDF features using character level engrams. So unigrams, bigrams, and trigrams. So as you see, vectorizer, TF, ID, vectorizer analysis character. Basically use 1 to 3 characters for engrams for a better language model. And then, yeah, transform the words into a TF-IDF matrix. Next, we encode the labels using label underscore encoder equals label encoder. Y underscore encode equals label encoder fit transform, fit dot transform. Finally, after that, we split our training data into or split our data into 80% of it being used for training and then 20% used as a test function or testing data. Um, so as you see, we have X train, Y train, X train, X test, and Y train, Y test. Um, down here. Finally, after we have our training data, we can now initialize all the different models we're using. So I just do that KN model 5 or SVN model and KNN model and SVM model and MLP, and then basically we create a KNN model with 5 neighbors, and then we create an SVM model with a linear kernel and an MLP with one hidden layer. Then we train all 3 models. So KN model.fit train Y X train Y train. And we do that for all the different models. Finally, we get predictions from each model after we finish training it. And then we are able to use this function to calculate the average. So calculate accuracy, predict labels, true labels, and target labels. We use these as variables. So we say correct equals Store the correct equals sum predictions. Basically, we count the number of correct predictions for the target language, and then we total the number of words of the target language in the test set that were in the test set, and then we finally return the correct amount, the number of ones we got correct, the code got correct, divided by the total times 100 to see if to get the accuracy as a percentage. Next, we get a label indexes for each language. So we just do English index and store label as in we do English index or language index as a variable and set it equal to label encoder transform and then our language 0 and then we finally use this to compute the accuracy for each model and language. So you can see here each model here using each language here. Finally, we print the accuracy results, and then we are now able to graph the result. So we just have our labels here, then we calculate the average of the correctness, then we use the average as the values for the bar graph. We title it using this and create labels, and then we actually draw it down here, and then we display the graph. So after running the code, this is what comes up. And this concludes the coding assignment, or the coding assignment 1.